of the important SCR parameters we have. So we have to consider those parameters while designing the SCR. The first one is latching current. So you know that this is the minimum current required to trigger the device from off state to on state. So it is the minimum current required to switch on the device into on state or trigger the device to change from off state to on state. Next one, holding current. So holding current is the minimum value of current required to maintain the device in on state. These two currents are not same. Latching current, if the device is changing from off state to on state, and if the device has to continue in on state for a longer amount of time, then a minimum amount of current called IH or the holding current is required to pass through the device to keep the device in on state. For if you want to turn off the device, then you can reduce the value of IH, then the device will be coming back to off state. How much ever negative input you give to the gate, it is not going to help you in turning off the device. So turning off the device completely lies with IH or the holding current. And next one, IG, gate current. IG, so gate current is the current applied to the gate of the device for controlling. So gate current will turn on your device. So gate can be used to turn on your device for a short duration. Okay, so minimum gate current is the minimum value of current required for triggering the device. Triggering means required for turning on the device. So this is three parameters: latching current, holding current, and gate current. So don't confuse. Latching current means the minimum current required to turn on the device. Holding current means the minimum current required to keep the device in on state. Gate current is the current which is used for controlling the device, for triggering the device. And the maximum gate current is the maximum value of gate current applied without damaging the gate. So gate is a terminal which is attached to semiconductor layer, right? So P layer, right? And that layer cannot withstand a huge amount of current. So that there is a limit for the maximum current which can flow through the gate. So that limit is given here, and by any chance you should not give current to the device more than the maximum gate current, because it will damage the gate. So more the gate current, the device will trigger early, but you have to be careful to ensure that the device is not damaged. Okay, so my minimum gate current and maximum gate current have values. When you purchase SCR, there will be data sheet, and those data sheet will have the value for all these currents: latching current, holding current, gate current, minimum gate current, maximum gate current. Okay, so all these will be there. Next one, voltage safety factor. So it is the ratio of peak inverse voltage. It is related to the peak inverse voltage, and it depends on the RMS value of operating voltage. So this voltage safety factor is given by peak inverse voltage divided by root 2 into RMS operating voltage. So this is a parameter which will define the safety of your diode, whether the device is operating in the safer range or it is in danger. So all these can be ascertained by calculating the value of VF. Normal value of VF lies between 2 and 2.7. For safe operation, the normal voltage of device is kept much below PIV. So naturally they say 2 to 2.7 means it is okay, but you have to ensure that this value is always below 2. You take the minimum limit, fix that as your threshold, and try to operate the device always below the 2, the voltage safety factor. And peak inverse voltage is the reverse bias voltage which is applied to your device. Okay, so this voltage safety factor, which is the ratio of the factors peak inverse voltage and RMS value of operating voltage. And there are a lot of applications of SCR.